Welcome back. Now we're able to fly around and things are looking good, but there are a couple of things I'd like to change. For one, I can't really move straight up and down. That's something that we were able to do with the default pawn, and I'd like to be able to do that here as well. So pressing the space key, for example, would be a nice way to do that. And in order to have an additional direction in our input action IA move, we'll need an additional dimension to our value type. We're going to need to use axis 3D vector. So I'm going to change it. Now this shouldn't affect our WASD movement, but it's a good idea to check and make sure we can still move, which we can. But we're going to want to be able to add an additional input to IA move. So far we have W, A, S, and D. I'd like to add the space key. So I'm going to add to IA move. It's going to come way down here in at the bottom. I'm going to click the keyboard icon and hit the space bar. But as we've seen, pressing a single key, by default, that axis value goes into the x-axis. So of course we're going to need to swizzle, right? So let's add a modifier and choose swizzle input axis values and expand it. Only we don't want the order to have Y first, we want Z first. So we're going to have to choose one of these drop-downs that starts with a Z. And now we should have input going into the Z axis when our spacebar is pressed. Now we need to handle that situation. Let's go back and find IA move. Notice that action value is now a yellow color. It's a traditional vector with 3 dimensions. And if we go into handle floating pawn movement, we'll see that our get right input vector, if we go into that, is still breaking our IA move, but it's breaking it into a vector 2D. Interesting, right? It's funny that that still works because this is no longer a vector 2D, it's just a vector, a 3-dimensional vector. But we could change this to break vector, and we know that that gets the 3 values that we would expect. And we can change this to get the X. And we don't need that weird break vector 2D. That just doesn't make sense. This is a 3-dimensional vector. Again, it's funny that it still worked, right? But now it looks as it should. And we can go back to our handle floating pawn movement and go into our get forward input vector. Again, break vector 2D doesn't make sense here. We can drag off and break vector and get the Y value for this and hook that in, and now that makes sense. And we'd also like another version of this that gets the Z-axis, only we don't want the forward vector, we want the up vector, right? So let's go back out into handle floating pawn movement, where we're calling add input vector twice. We're now going to call it a third time. So add input vector, except we're going to get the up vector corresponding to our control rotation. So we need get control rotation. We're going to drag off of that and type get up vector this time. And this we're going to multiply using a multiply node by the input action Z value. So we're going to find IA move, get that input action. We're going to break the vector and use the Z value here. Now, we can't just drag it in. That's going to convert from a float to a vector. We have to do what we've been doing and convert this pin to a float and drag in that Z value. And then we can hook this in to add input vector. And we can also collapse this to its own pure function. I'm going to do that and call this get up input vector and convert it to pure. And now we have a pure function for that one. And all of this is packaged into handle floating pawn movement, which we're calling here from the event graph. So let's see if we can press the spacebar and go up. And we can. So that's a nice touch. It's really nice to be able to elevate as we're maneuvering around. I don't really care so much about moving downward, but you know enough at this point to assign a different key to move down if you wanted to do that. Okay, so that takes care of that detail. And before we wrap up this video, I'd like to do one more thing, and that is show you a really cool feature of the spring arm component. Let's go into bot pawn, select the spring arm, and search for lag. And there's a very cool property called enable camera lag. Let's check that and just see what happens when we play test. Look at that. Our camera lags behind. It takes a little bit of time for the camera to sort of catch up with the movement of our pawn. And it looks really cool. It gives a little bit of juiciness to the game. Now, you might feel like that's too much lag. You can zero in on a sweet spot by going back and, with our spring arm selected, searching for lag, we can change the camera lag speed. Now, lag speed is how quickly the camera catches up. Low values are slower. So if you want the camera to catch up more quickly, we can increase this value. I'm going to change it to about 20. You can also set a camera lag max distance if you don't want the camera to lag farther than a certain distance away. 0 means there is no max distance. But I'm just going to try a value of 20 for the lag speed. I feel like that looks and feels pretty good, but of course, adjust it to your heart's content until you're happy with it. But now, this looks a lot better with a little bit of camera lag. It's just one of those nice little touches. It's subtle. You don't really notice it if it's not there, but if you don't have it, things feel a little too stiff, like something's missing, right? So this is one of those nice touches. Excellent. Now we have our drone pawn. We can fire, we can float. We're capable of doing battle. We're ready to move on. Things are looking great. Excellent job. And I'll see you in the next video.